Let us begin our next class, that is on fundamentals of electrical engineering. So today I am discussing about DC circuits. So what is DC circuit? A circuit which works on the DC supply is called DC circuit. We can see what's Ohm's law. We know what is Ohm's law. Ohm's law is the voltage across a conductor is proportional to the current flowing through the conductor, provided any physical conditions or temperature remains constant. Temperature remains constant. Only under that condition, Ohm's law can be true or useful. See, understanding why it is not an actual physical law is critical to understanding the basic principle of logic and the nature of physical laws. You can see here that diagram represents how actually the voltage is fed to the circuit, and a force is making, a EMF is actually making the current to flow through a circuit. That circuit consists of resistance. You can see here, this is how I can depict the Ohm's law. So Ohm's law is directly proportional. Ohm's law can be defined as the voltage across the conductor will be proportional to the current flowing through the conductor, provided the temperature or any other physical conditions remains constant. So after this Ohm's law, see, we can write the equation as V is equal to I into R. Voltage is equal to I into R. Next, coming to Kirchhoff's first law. There are two laws. One is Kirchhoff's first law, one is Kirchhoff's second law. You can see here how exactly it works.
This video is all about Kirchhoff's first law, or Kirchhoff's first rule, and it's all to do with the current and the conservation of charge. Now, current, I guess it's the flow of electrons, and although conventionally they go from positive around to negative, the actual electrons are going the other way around because they're negative charged and actually flowing this way around the circuit. Now, what I'd like to do is say that these little guys here are going to be my charge carriers, and what they're going to do, they're going to carry charge around the circuit. So this is a bit like the flow of electrons. So just bear with me for this analogy. You'll see these guys in a few more videos to come. So here I have my very simple circuit, and what I'm going to sort of represent this current flow by, or these charge carriers, are these the green army men here. And what we find is that if we were to measure the current at any point in this circuit, perhaps by putting an ammeter in series, we'd find that we'd have the same value for the current around the whole thing. The current doesn't build up, the charge doesn't all build up at one location. It tends to flow through and flow around this whole circuit. And this is the basis of Kirchhoff's first law. And we can look at that if we maybe think about one particular junction in a circuit. So here I have part of the circuit. Perhaps we have a current flowing in this way. I'm just going to think about conventional current. So the conventional current might be these guys along here, kind of all moving along. And what happens is when they move along through the circuit, they're going to get to this junction. So here we have my junction. Okay, and it's just any point where we have, I guess, wires kind of meeting in a circuit. Now, what happens is that when the current flows, it doesn't all just start to pool up and kind of all gather up here. What we find is that anything that comes into this junction will then leave it as well. So we might have a certain current coming in, and maybe some of the current goes out this way, and maybe some of the current moves out in this direction. So looking at that in a bit more detail, what we can say is that the sum of the currents into the junction is equal to I1. I've just labelled that I1, and that's equal to the sum of all the currents leaving the junction, which is equal to I2 plus I3. And we can maybe rewrite this as I1 minus I2 minus I3 is equal to 0. And therefore the sum, and this kind of M on its side here means the sum of the currents into and out of that junction is equal to 0. And this is Kirchhoff's, spelt with two H's and two F's. This is his first law. So Kirchhoff's first law is all to do with current. Remember, current has a symbol I, maybe the I looks a bit like a number 1. So this is Kirchhoff's first law, that the sum of the currents into and out of a junction are algebraically the same.
So that is the depiction of current law, Kirchhoff's first law, KCL. Next, let us move on to the next one. You understood that Ohm's law, which is equal to V is equal to I into R. It can be given as V into I is also equal to power. You can see here how exactly it's correlated. The power is getting increased. This is about understanding of Ohm's law. And this is Kirchhoff's current law. That is, sum of all the currents which are entering in will be equal to sum of all the currents leaving the node. We understood this very well. The Kirchhoff's current law. Both the diagrams are showing the sum of all the incoming currents is equal to sum of all the outgoing currents. See here, this is Kirchhoff's voltage law. So the Kirchhoff's voltage law is, you can see the total voltage is equal to sum of all the individual voltages in the circuit, in a closed circuit. This is, you can see the application of KCL and KVL. So this completes today's class. Let us discuss about applications and further the demonstration in the next class.